Donuts. Circular motion in physics and how it relates to acceleration and velocity. But we're not talking about these donuts. They're very delicious, but they have very little to do with physics. We're talking about these donuts. So how do cars do this? Well, first off, what is circular motion? Circular motion is the movement of an object along the circumference of a circle or rotation along a circular path. To show this, we have a toy car. Our car is moving in a circle. Let's watch it. That was our toy car. Now, what are the features of circular motion? Circular motion is a uniform motion. It is constantly changing direction, and the velocity vector is directly tangent to the circle. It is moving tangent to the circle. What are the other features of circular motion? The acceleration always points internally or towards the center of the circle. There is constant acceleration due to the constant change in direction and velocity. The inward direction of the force causes the change in direction, with the velocity vector angling inward, creating the circular motion. As you can see from this, the net force is pointing inward, and the acceleration is also pointing inward, and the velocity vector is tangent towards the circle. Lastly, the net force is towards the center of the circle, and this is required to obtain this motion. The force towards the center of the circle causes velocity to change in that direction, creating a circular motion. The net force is towards the center, which means that all other forces are lesser than that of the acceleration and the forces pointing inward. The features of circular motion also include that without the inward force, the vector would travel along a straight line, and there would be no circle. Lastly, this is what the movement should look like. The velocity vector angling tangent towards the circle, acceleration towards the inside. Now we want to show you the velocity of our car. So the velocity of the car was calculated with the equation 2 pi r over time. So 2 pi times the radius of our circle divided by time. In this example, we can see how the car moves in a circular motion and how the velocity vectors point along the circle. This is the information that we gathered from our video analysis. So it shows time as well as the x position. So this is the equation for velocity again, so 2 pi r over time. This equation comes from the calculation of the circumference of the circle, so 2 pi r, or 2 pi times the radius, and the distance around the circle, the circumference, is divided by time, which equals the velocity. So for our car, it traveled 3.68 seconds, and the radius was 1.016, and the calculations are as followed, giving us a velocity of 1.735 meters per second. We also are going to show the acceleration of our car and the vectors that go along with that. This is what our car's circular motion looked like. We have the acceleration pointing towards the center and the velocity vector that is moving tangent along the circle with a radius of 1.016 and a velocity of 1.735 meters per second. And this is our acceleration equation. So the acceleration is the velocity squared divided by the radius. And this is how we calculated it, which gives us 2.936 meters per second squared. And this is how it looks with all of that information on our circle. Now we know about circular motion.